In this demo, I want to show you how to use auto-constraint. Takes a little practice getting used to using this. This is going to be a very simple demo and it'll work perfectly fine. But I have a number of demos on how to manipulate the auto-constraints to get it to work in your favor. But you got to get the basics down so you can build on that. If you understand drafting and you understand dimensioning, you can really manipulate the auto-constraints. Uh, if you want to do baseline dimensioning or chain dimensioning, it's really good for that. One of the problems it has is dimension to points, dimensioning to angles, dimensioning to elements that are not going to come off your datum. So if you manually stick those in, it will pretty much do the rest for you. So you got to give it a little guidance. In this case, this particular part is datum dimensioned and everything is off the datums. If you don't know what the datums are, I've applied anchors. You'll see two anchors on the screen. Those act as your datums. You could also coincident the two datums to the axis itself. If you're in the shop, when you are looking at a drawing, you're looking for datums, and what the datums tells the shop is to make all the measurements from those edges. So they become your baseline or critical edges to measure from. So you want to constrain your part as if you were in the shop dimensioning it. So just a real quick demo on how to use auto constrain. You can create a simple profile. I'll just do that up 3, down, over 2, down 1, over 2, down 1, over 2, down 1. It'll automatically close out the profile. With that profile closed out, you can go right to the auto constraint command. It's going to highlight all the, it's going to take all the highlighted elements, and it says elements to be constrained are the 8 elements. On CATIA, datums are reference elements. So your reference element would be this line and this line over here. Again, what we call in the shop or design drafters call datums, CATIA calls reference elements, fixed, or anchored elements. Those are your 3 terms that means datums. Datums are actually isolated elements in CATIA, so quite a bit opposite of what we would consider datum to be on a drawing. So we're going to stack dimension it. So you have chain dimension and stack dimension are your 2 options. Stack dimension will do baseline dimensioning. I simply hit stack and say OK. Now the profile is not green yet, and the reason why is if I change this 6-inch dimension, it could go left, it could go right, it could go symmetrical. I really haven't controlled which way it's going to go. So what you want to do is you want to take these 2 lines and use the dialog box. Okay, so I call the constraints defined in dialog box, I just call it the dialog box. So if you hear me reference that in the future, this is the icon I'm referencing. We're going to apply the datums by hitting fix. Remember, in CATIA, datums are fixed, anchor, or reference elements. I'll turn off horizontal, perpendicular, and vertical. If you do not turn those off, it will not go through a check process through EVCC, engineering data control. It will recognize that as double dimensioning. It will be red H's and V's or black H's and V's, letting you know, hey, I'm a datum. I don't need to be horizontal and vertical because I've already established that I'm the datum and the horizontal and vertical are no longer relevant. I select OK. The part is green. Just like that, this profile is completely constrained. What that means is it has all the constraints it would need for a shop to make the part. It's fully defined. It's fully constrained. It's not missing any constraints. It's not over constrained. If it were missing a constraint, you would see, for example, if I delete this dimension, that line on top, the white line on top, is under constraint because I don't have that. So use the colors to your advantage. The white means under constrained and purple means over constrained. So if I try and put in a constraint, down here at the bottom, it's going to say it's over constrained. I've turned purple because it's over constrained. Because I already have that constraint here. You can't do it twice. There's no way I can be 8 inches on the bottom, 6 inches on the top, and maintain vertical lines. Okay, so it's just not going to happen. That's how you know you're over constrained. Those colors are set in your preferences. So if you go into your preferences and you do your legacy preferences, find mechanical design in the tree and look for Sketcher, third one from the top. You have colors. I've got the visualizations diagnostics colors on, so when I click on this, purple is over constrained. Inconsistent element means if I put in a 10-inch radius and the part's only 1 inch, it's going to say, hey, I can't do that. I can go 1/4 inch, but I can't go 10 inch. So if your constraint ever turns red on you, that's what's going on. You've defined something that just physically cannot do. The green means that it's a constrained element. Okay, so the white was the color right here. The default color is white. That's how it comes in. So you can change that color here if you want. If you're colorblind, you need to change some of the colors. You can adjust some of the colors. Problem with that is most people just leave that color the way it is. So if you go and change your colors, it's going to be weird to some people. I guess sometimes back in the day, I used to play a joke on people, and I would change this color to white, and no matter what they did, it would never be constrained. You had to be smart enough to know to go into analysis and hit sketch solving status, and it will say constrained. And I know, even though it didn't turn green, that it's actually constrained. Again, if I delete this constraint, the 3-inch constraint, and I do that solving status, it now says it's under constrained. I will put that constraint back. Oh, shoot. So I have to recreate that constraint. Didn't let me hit redo. So I'll put that constraint back from this line to this line. Whoops. Now it's turned to green. It's fully constrained. And again, under analysis, I have a constrained profile. You really shouldn't be building your solid until you have all this constrained. This should be a fully constrained profile. And you can't even start constraining it unless you have a closed profile. So the first mistake I see is people are building constraints and they don't even have the profile closed yet, and it's just going to force a non-closed profile to stay unclosed. So first step, close off the profile, make sure it's fully trimmed off. All lines are adjacent, meaning that there's no gaps and no overruns, and then you can do your analysis to verify that the profile is fully constrained. So again, you can watch how quick and easy this shape is to build. Let's turn this off. I remove the constraints. Okay. After you're done constraining the part, that profile will be highlighted. And if you don't know this, you can do an auto search on one edge and it'll find all adjacent elements. This is another way to check to see if the profile is completely closed. If it was not completely closed, it would not go all the way around. Okay. So now I know it's completely closed. I can go into Sketch and use the auto sketch. This is already highlighted, so it's already got all my elements in there. I'm going to go to references and select my references. Stack dimension it and select OK. Grab this line and this line over here and set those as your anchors. Remember the H and V's, they got to go, they can't stay, so you'll have to use the other technique I showed you. To get an easier way to get rid of them all at the same time is go to the dialog box and apply your anchors and remove these horizontal verticals. Okay, then you just got to move the constraints out to where you want them. Okay, another way to do this, if you know a specific coordinate you want to place that on, you build a local axis and then you apply constraints to link this to the local axis. I go into coincident and coincident this to this, coincident this one to this one. Okay, and then you can move out your constraints and do whatever you like. One of the reasons why I recommend building the part off and then linking the coincident, it makes it easier to switch your datums if you wanted to move them around and have a different point on that local axis. So on this example, I could always go back to my last coincidences I did and delete them. Okay, or I could pick this coincident and delete that, and then switch my datum edge to this surface by coinciding that edge to this vector. And now I've got my datum over here on that corner. Okay, if I delete this, and I go to rectangle, and I pop in a rectangle. Oh shoot, that should be in the, okay. So if I do it that way, what you'll see in my geometry is 4 lines, which is what I would expect to see. With my 4 lines, I should have 4 points. I got a point here, a point here, and a point here. I don't have a point on this corner. So when I try and move this way, I can move this one this way. I can't move this one side to side, but I can go up and down. Okay, so this corner can move, this corner can move, this corner can move. Okay, the corner that can't move is I've locked it down to that axis, and I can't do that little trick where I just did the last one, where I moved this to be linked over to this axis system. So you could find yourself in a bind if you draw on that axis. The only way to fix that really could be just to highlight the whole thing, delete, and then recreate your rectangle. Alright, so that concludes the exercise on how to use the auto constraints. So I would recommend go try and practice that. Build a simple shape, maybe build the same shape I'm building right now, and then go ahead and try and go right to auto constraint. With the remember the part's already going to be highlighted, so just go ahead and with that already highlighted, go right to auto constraint. Set your baseline dimensions as your anchors. Stack dimension it, select OK. Select these 2 elements. Turn on the dialog box. Apply your fix. Turn off the horizontal and verticals. And the perpendicular is not really needed. And that part's fully constrained just like that. No fuss, no muss, just let the computer do the work. That's why we have the computer. It's supposed to do the work for us. Hope that helps you at least get the basic concepts of how to use auto constraint.